Hey there, Intro to Calc peoples. This will be the third video in my little series of videos on how to do the stuff that you need to do be able to do calculus, namely the grade 11 skills review. And my previous videos, the first video I did 1 and 2. The second video was a big long one. I did 3 to 8 and page 3, which I don't know where I set down. There it is, and page 3, which is long division. And on this one will be shorter. Let's just do a quick refresher on how to simplify compound rational expressions, which you did a little bit in grade 11, and how to rationalize denominators, which you also did in grade 10 and 11. But of course, here in grade 12, we're going to kind of pick up the skill level necessary, because this is probably a little more algebraic than you ever saw back in earlier grades. This time I'll actually not make up new examples. I'll actually just do ones from your homework. So if you're completely stuck, watch how I do these ones and then try the rest on your own. So how do you do this? Well, it says that we want to simplify this. And to simplify it, well, if you're subtracting fractions, you know that you need a common denominator. So my common denominator for the top here is going to be whatever x plus 2 times 2 is. So think about how regular fractions work. If you had two fractions that didn't simplify, and I don't know, like say for example 3/7 and 1/8. Well, since you know that they don't simplify and that there's no common factors of 7 and 8, then the common denominator is just going to be 7 times 8. So that means I'm going to have to times the top here by 8 over 8, and the top and bottom here by 8, and the top and bottom here by 7. So that's how I would do it. I'd go, that's 24 over 56, and that is of course 7 over 56, and then I add them together. Okay, algebra doesn't work any differently. If things work for arithmetic, they should work for algebra. So I'm going to take 1 over x plus 2, and I'm going to times top and bottom here by 2. And here I'm going to times the top and the bottom of a half by x plus 2. If you don't want to show me this step, you don't have to. I'll know what you did if I see your work properly. And so that's going to be 2 minus x plus 2, but don't forget that minus is going to have to be distributed through the whole bracket. So that's going to be 2 minus, I'll put the bracket still on there so that I don't forget to distribute it. And then the bottom is going to be just 2 times x plus 2. And remember, nothing here cancels. No, I can't cancel those 2's. This is done. And all of this is still over x. All right, I'm going to do a couple things in this next step. First, I'm going to simplify this. 2 minus x plus 2 is, well, if I distribute the minus, I'm going to get 2 minus 2. So the top here is just negative x. The bottom here is 2 times x plus 2, and I'm still dividing by x. So now in the next step, how do you divide by x? Well, think about how you divide when you're in fractions. If you have a fraction divided by a number, when you're working in fractions, you can change all divides into times the reciprocal. So I'm going to take this fraction, and I'm going to times it by the reciprocal of that fraction. Think of this, if you like, as x over 1. So the reciprocal of that is 1 over x. Now I do see another cancel. I see that that x and that x cancel because they're factors, not terms. So x divided by x is 1. So my final answer is going to be negative 1 over 2 times x plus 2. And when you look at the answer key, it's actually going to leave it like that. It won't bother distributing that 2. You're going to see that in this calculus course a lot, that unless there's a good reason to put an answer back into an expanded form, we're happy enough usually with the factored form. Also, most questions like this talk about what are the non-permissible values. Well, in this case, this thing is only really equal to this thing as long as x isn't two different numbers. X cannot be negative 2 or 0. Can you see why? Back in the very first step, if x was 0, then I'm dividing by 0 and the game's over. And here, if x was negative 2, negative 2 plus 2 is 0, and even if only one part of an equation is a divide by 0, then that equation or that expression just doesn't exist. So there we go. That'd be my answer. My answer would be, this is the simplified form as long as x isn't those two things. So that's rational expressions. The number 10 question is about rationalizing denominators. Okay, let's do a quick history of rationalizing denominators. The first kind of denominator you had to rationalize was just a simple radical in a denominator like this. And simple enough, we multiply by 1, which doesn't change the value of this thing, but that's what my 1 looks like. So 1 times root 2 is root 2, and then root 2 times root 2 is 2. So there we go. I now have a more, to a mathematician, simplified answer than that, because it doesn't have a radical in the denominator. Then you moved on, that was what you did in grade 10. In grade 11 you moved on to maybe more complicated ones, like say for example you had 2 over, I don't know, how about 1 minus root 2. And here you had to use the conjugate rule, which basically says that you're still multiplying by 1, but your 1 now is going to be the conjugate of this denominator. And why you're doing that is because, check this out, 2 times the numerator is 2 plus 2 root 2, but now the denominator, FOIL this out. First times first is 1, outside times outside is plus root 2, inside times inside is minus root 2, and last times last is minus 2. And look what happens. Those two radicals go away. They are opposites. They cancel. And then I have 2 plus 2 root 2 all over 1 minus 2, which is negative 1. Dividing by negative 1 is not very exciting. I'll just put that negative on the top, and that's the kind of thing you were expected to do back in grade 11. Now, oops, sorry, I'm off the page. Back in grade 11. Now we're going to do it with more algebra. You might have done some of like this that were algebraic also in grade 11, especially again those of you in the honors program. So let's try an algebra one. This is a radical and that's not a radical, so I've got to do the same thing I did here and use my conjugate rule. So I am going to multiply the top and bottom of this fraction by the conjugate of that, which would be this term plus 1. And remember, you have to times the top and bottom by the same thing, or else it's not a 1. And if this isn't a 1, then you're changing the value of this instead of just rearranging and rationalizing its denominator. So the numerator will be x times root x plus 1 plus 1. And again, you know what? There's probably not much reason for me to multiply that out. I don't think it's going to help me any. So maybe later I'll decide to multiply that out. For now, I'm just going to leave it. The bottom is where things are really happening. It's going to be first times first, which is x plus 1. Outside times outside, which is plus root x plus 1. Inside times inside, which is minus root x plus 1. And then last times last, which is minus 1. And again, notice that that radical and that radical are opposites, so they cancel. So on the top I have x times square root of x plus 1 plus 1. And on the bottom I have x plus 1, all that gobbledygook canceled, minus 1. So I have x. Hey, it's a good thing I didn't multiply that out. It would have been a waste of time. This final answer is x square root of x plus 1 plus 1. Can't simplify it any more than that. So try the rest of them in number 10 and let me know what you think. If you're stuck on any, message me, or if you're coming in for class, come on in and ask me about them and we can do some more together. Thanks for watching.